Hello, welcome to Lesson 6.2, Day 1. In 6.1, we've dealt with law of sines. There are two cases that remain in the list of needed ones that would solve the oblique triangle, side, 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 and side, angle, side. If you're given three sides, or two sides in the angle including those two sides, then none of the ratios for law of sines would even work or be completed. So in that case, we're going to use law of cosines. So here you want to copy these down for the standard form. In other words, if you're looking for a side length, or the alternate form where you're looking for an angle. And it's going to depend on what parts you're given. I'm going to work a couple of example problems. They are from the book, and it's going to be an even problem, so it's just for yours as an example, but it's going to be number 6. I'll put it right next to it. This one is going to be the side, side, side case. So they are giving us that A is 55, that B is 25, and that C is 72. So you can see we're given all three sides. And what they ask us to find is to solve the triangle. So we're supposed to find all the other angles. I'll go through one where we find one of the angles. You can practice on finding the second one, and then the third one will be adding the two that we find and then subtracting from 180. So first off, we need to because of our formula, we could actually pick either of the angles because we have all of the other parts. So let me go with, I'm going to pick C. So I'm going to use this bottom one, so I'm going to write cosine of angle C that would be A squared plus B squared minus C squared all over 2AB. So by plugging into this, I can see that cosine C would be 55 squared plus 25 squared minus 72 squared all over 2 times 55 times 25. Just plugging straight into there. Now I can type all this in, and on your Inspire, and the control of the division key has the little fraction template. That works very handy. You can type all this in on the right side. And then recall that once I find, when I type this in, I'm going to get approximately negative 0.5578, and then I need to do the inverse cosine, which will give me C, inverse cosine of that decimal, and then I'm going to round to 2 decimal places, and that gives me 123.91. By plugging in, what you want to do next is solve this for cosine A. The same process, but I'll start you out and see how we would plug in. So just from the formula in this chart right here, we would see B squared plus C squared minus A squared over 2BC. And so by plugging in the values from the same problem, we'll be able to solve for A. And then to find angle B, we're just going to add the angle A and angle C, and then subtract from 180 to find the leftover one. The other type is one like, pick number 10, and this one is giving us angle A, 135, and it gives us Sorry, I wrote the wrong one. Sorry about that. It is 55 degrees. And B is 3 and C is 10. Now this one, because we have the angle, I'm going to use the formula where I have the angle A in it on the right side. So that's the one that says A squared equals B squared plus C squared minus 2BC cosine A. So by plugging that in, I see I have 3 squared equals 10 squared plus, sorry again, the A squared is what I was looking to find. I'm sorry, I jumped the gun. 3 squared plus 10 squared. Thank you. You're probably already fixing it for me. Minus 2 times 3 times 10 times the cosine of 55 degrees. Now, because A squared is going to equal all of that stuff that we're going to type in, and you can type it all straight into the calculator, then it's going to be, I'm going to put an approximation symbol, 74.585, but that's A squared. So then we will square root, and we get the A value, and we're going to approximate to 2 decimal places like we did the last one. So depending on which part you have would depend on how you set it up or which formula you're going to be looking to solve for. That is all.